guys had issues with intervals of increase and decrease. So we're going to talk about that. So the reason I did this was so I could see kind of where you guys are at with finding key features. All right. Because trust me, those will haunt you all through Math 3 and everything else. Key features are a pain, but you got to know them. Of course. Every time. All right, so check your answers for the first part of the warm-up on page 14. All right, so just the key features piece. So direction of opening, it's facing upwards. So direction of opening is another name for concavity. Axis of symmetry is x equals 2. Remember, you got to put the x equals. It has to be a line. Vertex is at the point 2, -1. It's a minimum because it's the lowest point. Y-intercepts at 0, 3. X-intercepts are at 1, 0, and 3, 0. The domain is all real numbers. So from negative infinity to positive infinity, and the range is from -1 to infinity, because your lowest y is -1, and it goes on forever upwards. Yes.
Why is it not bracket on the right side? Why is it?
All anytime you have infinity, it's always parentheses. Sorry, it's negative. Now, it didn't ask you to do this, but let's talk about increase and decrease. All right. So, interval of increase and decrease. So, for intervals of increase and decrease, there's two stipulations that has to happen to it. What's the first one? So what values do we use only in intervals of increase and decrease? The x values. We only use x's. We don't use y's. What about the notation? So like brackets, parentheses, can we use a mix of them? Can we only use one of them? What do you think? Parentheses only. All right. Now, when we're doing intervals of increase and decrease, what does that mean? So if I'm saying an interval of increase, what am I looking for?
Like which parts of the parabola increase?
Right. So in other words, if I run my pencil from left to right, I'm looking where my graph is going down and where my graph is going up. Where it's going down is your interval of decrease, where it's going up is your interval of increase. What kind of shows us our stopping and starting points for those intervals? What key feature gives us that? The vertex. All right. And since we're only using x values, it's the x value of the vertex. Okay. So remember, this is the one where I said you should probably start by just identifying where the intervals of increase and decrease are. So I said always start from left to right and just run your pencil along it until you hit the vertex. So was I going up or down there? Down. So interval of increase or decrease? Decrease. Then hit the turning point and I go in the opposite direction. So am I going up or down? Up. So interval increase or decrease? Increase. So if you take the time to do that first, it's really easy to figure out where it is. All right? Because let's do interval of increase first. At what x value does my interval of increase start?
2.
At 2. Now remember, we always use parentheses because why do we use parentheses? Why did I tell you yesterday you have to use parentheses and not a bracket for 2? Think about what bracket versus parentheses means.
So we just up the front.
Say it again? So brackets mean that it's included or it's defined, but does x equal 2, is it increasing or decreasing? Which one? So at x equals 2, is it increasing or decreasing? It's neither. All right. So because it's neither, it's like a gray area. All right. That means that it'll get really, really close to 2 when it starts increasing, but it doesn't actually define at 2 when it increases. So remember, brackets mean defined, parentheses mean technically undefined, but it gets really, really close. So we have to kind of use parentheses to say, okay, it looks like it's hitting here, but technically not quite. All right. Where does it end? The interval of increase. What's the highest x infinity? All right. What about the interval of decrease? Where does it start? Negative infinity. Good. Where does it end? 2. All right. So again, intervals of increase and decrease are not necessarily hard. It's just they have some stipulations to them. You have to use x values only. You have to use parentheses, and you just need to know where your graph is decreasing, where your graph is increasing, and you're using your vertex as kind of the start-stop point. All right. Does everyone kind of understand increasing and decreasing a little bit better? All right. And again, use the pencil trick because honestly, it just gives you a better visual. All right. Okay. Now, part 2 was they wanted you to put it into the standard form of a quadratic, which is y equals ax squared plus bx plus c. And they wanted you to state the leading coefficients. So these are my standard forms, and my leading coefficients are listed on the side. Now, for letter B, because some of you are asking this, you want it so there's only y on one side. Because it says y minus 5, we actually just have to move the 5 using inverse operations to the other side. So we just add the 5 to the other side. Right? Because some of you were like, what do I do with this 5? You move it. So keep that in mind when we get to solving in a couple weeks, because that's actually a big piece of solving. All right, any questions on number 2? All right, so today what we're going to be doing is we're going to be talking about the standard form of a quadratic formula, so the y equals ax squared plus bx plus c. We're going to be talking about how we can find key features from it without a calculator. All right. So instead of actually looking at the graph physically, we can find certain key features from the standard form without having to use a calculator or a graphing calculator or graphing it to see what's actually going on. All right. Also, were there any questions from the homework last night before I move on?
It was like number 5 on the 3.2 part. Like I don't understand what it's asking.
So with number 5, it was saying put the missing output, so fill in these blanks. And all it was saying is that you kind of had to, they told you what the vertex was, which was 3, -8. So, that's where it changes. And remember, what's special about quadratics? They're what? Symmetrical. So, if this is the turning point, what does x equals 4 have to be equal to? What's the output? If it's symmetrical? -6. Because what happens is, after you hit the vertex, all the points on the other side should be symmetrical to each other, meaning they should be the same thing. So, since 2 away from the vertex is 0, that means this one should be 0. Since 3 away is 10, this one should be 10. 4 away is 24, so this one has to be 24. So does that kind of clear it up? Was that the issue? Okay. So you just had to realize that they're symmetrical. So since we have the vertex, and if you looked at the x values, they're actually the same distance away from the vertex. So 2 and 4 are both 1 away. 1 and 5 are both 2 away. 0 and 6 are both 3 away. Negative 1 and 7 are both 4 away. All right. Any other questions? All right. I forgot to post the key, but I have it ready, so I'll post it by this afternoon if you need to check anything. All right. So let's look at the standard form of a quadratic equation or a quadratic function, however you want to put it. So, like I said, the standard form of a quadratic is this. So f of x is equal to ax squared plus bx plus c. Out of all things in this unit, you need to remember that. Okay? Ax squared plus bx plus c, because trust me, you'll be seeing it again and again and again in this class. All right? Now, remember, it's still a parabola-shaped graph. All right? Now, that shape we can tell based off of the a value. So, if it's going upward, that means our a value is positive. If it's facing downward, that means our a value is negative. All right, so just by looking at the a value of our standard form, we can figure out, just determining whether it's positive or negative, we can figure out what shape our parabola looks like, whether it looks like a upside down U or a U. Now, the axis of symmetry we can get by using this formula. So we take the b value, make it negative, divided by 2a. That's our axis of symmetry. The y-intercept is just the c value. All right, it's kind of similar to slope-intercept form. So you guys remember y equals mx plus b? What was the y-intercept? The b. So in other words, the constant. Same thing. Usually the constant of any standard form polynomial is the y-intercept. All right, so that's why the c is the y-intercept. All right, and then lastly, for the vertex, so the vertex, all right, the b over 2a that we got from the axis of symmetry, that's our x value. The y value would be what happens when we plug it back in to the original function. So we would have to take the b over 2a and plug into the function to find the y. All right. So for the vertex, the axis, whatever we got for the axis of symmetry, that's the x value of the vertex. The y value is when we plug that x value back into our original function. All right. And they just kind of repeat that here. So again, axis of symmetry is this formula, negative b over 2a. That's something you've got to remember. And then the y value, that'll be f of negative b over 2a, meaning you plug it back in to the function and evaluate it. All right, so let's try this. So we're going to find the y-intercept, the axis of symmetry, and the vertex all by hand. All right. So first off, let's just list our a, b, and c values so we're good with that. Okay. So a, b, and c. What would my a value be, Tucker? 1. Good. What would b be, Sailor? Not quite. Negative 9 is actually the c. So 0 would be the b. Now, Why is that? Well, if we look at the original standard form, A, B, and C are always consistent with the variable connected to them. So A is always connected to the x squared. B is always connected to the x, and C is always by itself. All right? So if you don't have an x value, you technically don't have a b value. It's 0. All right? Now, the y-intercept comes from what value? The c. So what would my y-intercept be as a point, Sutton? Mm-hmm. Good. So the y-intercept would be 0, -9, because that's our c value. Now, axis of symmetry, remember it's -b over 2a to get it. So I'm just going to put it straight into the formula. So -0, which is just 0, over 2 times 1. So that'll be 0 over 2, which is just what? 0. So how would I write my axis of symmetry? X equals 0. Now, the vertex, we would take this 0. That's the first value of our vertex. All right. The other value, that means we would have to take f of x and find f of 0. So real quickly, I'm going to plug in 0 into my original function. What's 0 squared? 0. Subtract 9. What's 0 minus 9? -9. So what's true about the vertex in this case? It's also the y-intercept. Okay. So if we were to get kind of an idea of what this graph actually looked like. All right. First off, my vertex would be at 0, -9, so it'd be right here. Axis of symmetry would be what? X equals 0, which is what on the graph? The y-axis. The axis of symmetry would be right here. Now, based off of our function, is the vertex going to be a max or min? A min. Why? The A is positive, meaning it opens in what direction? Up. So it'll look something like this. Now, we don't know what our x-intercepts are just yet. All right, and that's okay. But at least now we get a general idea of what it's going to look like. Okay? So let's try another one. So, first things first, we're going to list A, B, and C. Now, once you get good at this, you can kind of skip this step. But for right now, we're just going to write it out just so we have something to reference. All right, guys, clamshell your computers for me, please. Okay, so Natalie, can you tell me what A, B, and C are? Uh-huh. Good. So, what would my y-intercept be, Shelby? So 0, -1. Good. Okay. Now, take a minute and do -b over 2a. Yeah, it would help if I could hear. So yeah. Uh-huh. Yeah. Uh-huh. That's my fault.
Oh, sorry.
Yeah, it's the point. Yeah, it's the point. All right, so take a minute and do -b over 2a to find the axis of symmetry. So you're just finding the axis of symmetry. So you're taking the B value, taking the A value, plugging it into the formula. All right, thumbs up if you're ready. Okay. Let's go with Blake. What is my axis of symmetry? Where's it at?
X equals 4.
Good. So if we work down negative b over 2a, we would have negative 8, because our b value is positive 8, over 2 times negative 1, so that's negative 8 over negative 2. The negatives cancel out, and 8 divided by 2 is 4. So be at x equals 4. So that also means that the first part of our vertex is 4. The x value of our vertex is 4. Okay? Take a minute and find the y value. So how do we find the y value again of the vertex? Plug it into the function. So be careful. Make sure you're using PEMDAS and everything. All right, thumbs up if you're ready. All right. So what would my y value of my vertex be, Lizzie? -1. Okay, did anyone else get anything else? Okay, let's go Reagan.
I got 11.
Okay, so I also got 11. So again, we gotta be careful with your PEMDAS. So you gotta do within the parentheses first, and remember, since the negative is already included in the function, you put it on the outside. So you do 4 squared, which is 16, and apply the negative to it. Okay. Then 8 times 4, 32, minus 5. I got 32 minus 5 is 27, but minus 16 is 11. Okay, so I'm assuming what threw you guys off was that negative there. So again, the negative, if you're plugging something in for x, unless the x value itself is negative, if the negative part of the function, leave it on the outside and you square something. And then apply it after you square it, because you're technically multiplying by negative. So by PEMDAS, you do x on 4 multiplication. All right. Any questions on finding those 3 key features? Now, based off of our function, do you think this graph will open up or down? It'll open down. Why? A is negative. So it opens down. And will the vertex be a max or a min because of that? Max. So what would the shape look like? Would it look like a U or an upside down U? An upside down U. So it looks something like that. All right. So let's look at how we would identify and graph without using Desmos. Okay. So what I want everyone to do right now is take a minute on your own. I want you to find the y-intercept, the axis of symmetry, and the vertex for the function for number 3. All right, I'll give you guys 3 minutes. So at 8:33, move on. So everyone should be trying this. You don't need to graph it just yet. I just want you to find those three key features. Just all right, thumbs up if you're ready. I'll give you guys one more minute. All right, what is my y-intercept, Caitlin? Good. And how'd you know that? Good. Your C value is -3. All right. What is my axis of symmetry, Ashlyn? Good. And how'd you set up your formula? Okay, so what numbers did you put in specifically?
-8/2 times -2.
Good. So that would have been -8 over -4, which gives you the 2. All right. What'd you get for your vertex, Audrey? 2, 5. So how'd you set it up to find the y? Mm-hmm. So you get negative 2 times 2 squared plus 8 times 2 minus 3. So negative 2 times 4 plus 16 minus 3. Negative 8 plus 16 minus 3. So that gives you 8 minus 3, which is 5. All right, now let's graph what we know. All right, so we're going to graph those 3 key features. So I'm going to graph my y-intercept at 0, negative 3. I'm going to graph my vertex at 2, 5. I'm going to go ahead and draw my axis of symmetry. So just draw a dotted line through x equals 2. Now, what direction will my graph be opening in?
Down.
Down. How do you know?
The vertex is
A is negative. The A value is negative, so our has to open down. So our vertex is our max. All right. Now, to make a general shape, we can at least get one more point using symmetry. All right. Because in reality, your axis of symmetry is almost like a line of reflection. All right. So remember way back at unit 1, what's true about a line of reflection? How do you find a point reflected over a line? Right, you count out the distance from the line, it should be the same distance on the other side. All right. So we got the y-intercept, which is outside of the line reflection, it's not on it. So if I wanted to find a point that's symmetrical to this y-intercept, where would it be? It would be at 4, negative 3. Good. Because if you count it, 1, 2 from the line of symmetry, so it has to be 1, 2 on the other side. So that will give us a third point. All right. And the reason I did that is because now we got a general idea of what this graph's going to look like. So guys, that's a trick that you can use if you have to graph and you don't want to keep plugging in random numbers into the function to see what you get. All right, you only need to really put in like 1 or 2 numbers, and then the rest you can use symmetry to figure out. Does that make sense? All right. Now, do I need to go over number 4 with domain and range? Are you guys pretty solid on that? Okay. So let's just go through the first 3 key features quickly. So what would my y-intercept be, Danny?
9, 0, 9.
0, 9. Good. My axis of symmetry would be negative 6 over 2 times 1. This would be negative 6 over 2, so negative 3. So x equals negative 3. So that's the first of my vertex. And then the rest of it would be negative 3 squared plus 6 times negative 3 plus 9. So this will be 9 minus 18 plus 9. 9 minus 18 is negative 9, plus 9 is 0. This will be 0. So I'm going to take a minute and just graph those 3 key features. So I got the vertex at negative 3, 0. Y-intercept at 0, 9. Axis of symmetry at x equals negative 3. Now, using the y-intercept and the axis of symmetry, what could be another point that I can also graph? So using the y-intercept and the axis of symmetry. Right, negative 6, 9. So it's 3 away from the axis of symmetry, the y-intercept is. So if I count 3 away on the other side, it would be right here. So What direction is supposed to open up? It opens up, all right? Because the A value is positive. So our graph will look something like this. Now, for this particular graph, what's true about the vertex? It's also a what? It's also a 0 or x-intercept. All right. So this is one of those special cases where this quadratic only has one x-intercept instead of two. It's because the vertex is the x-intercept. Now, domain. What did I say is always the domain of a quadratic? All real numbers. So from negative infinity to positive infinity, or you could write it as the big R with a line through it. That's the shorthand for all real numbers. All right. Range. What would my lowest y value be? 0. So would I use a bracket with that or a parenthesis? Bracket. Where does it go to? Infinity. And you always use a parenthesis with that. All right. Any questions on how you would find y-intercept, axis of symmetry, and the vertex? Okay. It's your lowest y value. So this is your x value, the -3. You want the y value. It's on the x-axis, that y value is 0.
For range, is there always going to be a bracket next to the number, or does it like switch?
There's always going to be a bracket next to the number. For
Okay,
range.
there's always a parenthesis by the infinity.
Yep. Infinity is always a parenthesis because remember I said this yesterday, but infinity is technically not a number, it's a concept. It just means it goes on forever, but we don't actually know what that number is defined as. All right. Any questions on that? All right. So let's look at number 5 for a second. So the path of a ball is modeled by this function, where x is the distance down the field and y is the height of the ball. And it wants to know what is the maximum height of the ball. All right, so let's break this down. If we're talking about a maximum height of a ball, okay, first off, let's just look at the function itself. If we were to graph this function, would it open up or down? It would open down because we got this negative right here. All right, so if I just drew a quick sketch of it, it looks something like this. Now, it wants to know the maximum height of the ball. How do you think I would find that? What key feature do you think it's going to connect to? The vertex. So we need to find the vertex in order to figure out what the max height is. Now, how can I do that?
First find x by using the formula negative b over 2a.
Good. So we do negative 1.4 over 2 times negative 0.035. Now, guys, when it said no calculator, it just meant no graphing calculator. Okay, we can use like a regular calculator for this, just for the computation. So if I use my calculator, just put that in. As soon as it opens, I have negative 1.4 divided by parentheses 2 times negative 0.035. So 20. Now, that is the x value of my vertex. Now, let's see if we can stop here. If we're finding the maximum height of the ball, will this x value represent my answer? No. What are we actually looking for? the y value of the vertex. So this is going to come from the y value of the vertex. So now we need to put 20 back into our original equations. This will be negative 0.035 times 20 squared plus 1.4 times 20 plus 1. And again, I'm just going to type this into my calculator. So I have negative 0.035 times 20 squared. Oh, why did I do that? Plus 1.4 times 20. What was the last number? Plus 1. We should get 15. So make sure when you're typing it into your calculator, you use the appropriate parentheses. Your calculator should automatically do PIMBOS. All right, but make sure you put at least the 20 parentheses when you square it so that it doesn't actually include the negative 0.035 into the square. So this is 15. So what's my maximum height? 15 yards. Good. All right, now, last thing. So for number 6, okay, we kind of already did this a little bit, but it wants us to determine whether we have a max or min, and then from there, figure out the max or minimum value, and then the domain and range, okay? So first off, let's put this in standard form. So what would this function be in standard form, Tyson?
Fx equals negative x squared minus 6x plus 2.
Good. So based off of the standard form, would we have a max or a min? Max, why? Right, a is negative, so we have a max. Now, when we say max or minimum value, we're talking about the y value of the max. All right, so if it ever says the max or minimum value, they're talking about the y value. Now, what typically represents our max or min? What's the feature? The vertex. So we're finding the y value of the vertex. Well, to find the y value of the vertex, we need what first? The x value. So we're going to do negative b over 2a. So this will be negative times negative 6 all over 2 times negative 1. Now, why did I multiply this by a negative?
So,
But why did I do it?
it's already.
It's in the formula. So it has to be a negative version of the b. In other words, it has to be the opposite of what b already is. Okay? So the biggest mistake that I see people make is that because it's already negative, people assume they can just leave it as negative 6. You gotta make sure you flip the sign. Okay? So this would be 6 over negative 2, which is negative 3. So that's our x value. Then to find the y value, what do we have to do? Plug it back into our original function. So this would be a negative times negative 3 squared minus 6 times negative 3 plus 3. What's negative 3 squared? Positive 9 times a negative. Negative 9. What's negative 6 times negative 3? Positive 18 plus 3. Negative 9 plus 18 is what? 9 plus 3? 12. So our max value is y equals 12. That's our maximum value. Because our vertex is the point negative 3, 12. Now, domain should always be the easiest thing you ever have to find. What's a domain always? All real numbers. So guys, domain, especially if it's just a regular parabola, it's not saying that it starts or stops anywhere, like it's not just a bunch of points in a parabola-like shape. The domain's always going to be all real numbers unless stated otherwise. Okay? Now, what about the range? So, since it's a max, all right, if you need to visualize it, just kind of draw a quick picture of what a maximum looks like. And this would be the point -312. So, what would my lowest y value be? Negative infinity, because it starts low. What's my highest y value? 12. And that's your range. So again, even if you don't have the graph, if you know that it opens downward, you can at least, draw a quick sketch of it. So at least you can kind of visualize what it's going to do. Yes.
Could I reverse shape and click the boundary from?
No. It always has to be in order from least to greatest. So again, guys, interval notation is always from least to greatest. Yes.
So those 12 and positive infinity would switch, or that's not how it works?
So if the 12 was a minimum, yes, it would switch to 12 and positive infinity. Yes. All right, so here's what we're going to do. I want you guys to take about 5-6 minutes and try 1, 2, and 3. So I'll give you guys till about, let's say we'll figure out where we're at 8:57. And then we'll come together and answer these last 3 questions. All right, so try 1, 2, and 3 on your own. And then we'll come back together and go over them. Oh, guys, one more thing, just because I forgot to mention it, has nothing to do with the lesson, but since we're at the end of the term, Unit 3, everything Unit 3, so all the homeworks, everything is going on the next term. All right, so pretty much your grades are pretty much finalized unless you're still have some missing ones to turn in. All right, that's like if you were absent and you just had to turn in a homework or something. Okay. But you can still do test corrections at least on your Unit 1 test. Okay, I'm not taking them for 2A or 2B because you already kind of had that. But Unit 1, you can still do test corrections at least until Monday. So Monday's kind of my last day for test corrections. That's technically the last day.
Use your calculator to scan actually. Use for graph.
So guys, what you're doing is you can use a calculator for like calculations, but you can't use it for graphing purposes. That's right, yes. That's not true. Yeah. 4 minutes. Let's go back. All right, thumbs up if you're ready. All right. So let's go over this. All right. So for number 1, it asks you to figure out which one of these 4 equations could possibly fit this graph. So by show of fingers, obviously 1, 2, 3, 4, which one do you think it is? Good. It would be 3. Now, can someone raise their hand and explain to me why they think it's 3? Let's go, Reynolds. Good. So the A value is negative, so it has to be opening down. And since the Y value is positive, then it has to be somewhere above the x-axis. So 1 could have been a viable choice as well. The only difference is that the y-intercept is negative. All right. So I would say 3 would be your closest. All right. Number 2, it asks you to find the range based off of this table. All right. So show of fingers, what do you think it is? 1, 2, 3, or 4? All right. Most of you are holding up 4. Good. So why do you think it's 4? Let's go, William.
Because the middle one is the highest it goes. And on both sides it goes down.
Mhm.
So it's opening downwards.
Mm-hmm.
And that means the highest number is 11 or less.
Good. So it looks like our vertex is right here. Because if you look, it starts going in opposite directions, or it starts repeating itself after that 11. And it looks like it's going down. So the y values are getting lower on each side. So that means the 11 is a max. So it has to be less than or equal to 11. All right. Last one wants to know what the range is if they give you the axis of symmetry. So what do you guys think? Show fingers. I see some 3s. I see some 2s. All right, so let's go through this together. So we already have the axis of symmetry. So I just need to find what the y value is of the vertex by plugging it in. So I get negative 6 squared plus 12 times 6 minus 11. 6 squared is 36 times a negative is negative 36 plus 72 minus 11. This would be 36 minus 11, which is 25. Now, would this be a max or a min? So would the 25 be your maximum value or your minimum value? Maximum. Why? A is negative. So obviously the only one listed is 25, but it had to be less than or equal to because it's a max. All right, any questions on any of this? All right, so your homework for tonight is pages 16, not 16, pages 18 and 19. Now, you are allowed to use a calculator, but you cannot use it for graphing purposes. Calculators for computations only. All right? So you can use a calculator on this, but you can only use it in terms of, like what a calculator was originally meant for. Okay? No graphing with it. 18, 19. All right, while you guys are working on that, you've still got about a solid 20 minutes left. I'm going to come around and check off the homework from last night. Yes.